Hi there. Today I'm going to tell you the story of membrane receptors, which includes G proteins, cyclic AMP, and signal transduction. To start things off, I'm going to introduce a few of the friends I will be using to demonstrate today. First and foremost, my name is Elizabeth Fretcher, and I will be the narrator of the story. Our next character is ligand. Ligand is a signal molecule that will be binding to his much larger friend receptor, and ligand will also start off our story for us today. This right here is our heterotrimetric G protein, and as you can see, he has three parts to his wonderful personality. The first part is going to be the alpha subunit, the next part the gamma subunit, and also the beta subunit. As you can see, GDP is attached to the alpha subunit. They are partners in crime. GDP is always attached when the heterotrimetric protein is in its inactive state. The next character we're going to introduce you to is GTP. GTP and GDP are both nicknames. GDP stands for guanosine diphosphate, and GTP stands for guanosine triphosphate. GTP also wants to be a friend of alphas, so we will see what happens later when he comes into the story. The last person we want to introduce you to is ATP. ATP will also come into the story later, and we know ATP as the gold of the cell, or the energy of the cell. Alright, so now that we've set the scene, let's go ahead and get started and see what happens. Let's go back to ligand, the signal molecule. So ligand decides that he's going to attach to our metabotropic receptor because he thinks the metabotropic receptor needs to change. He binds to the receptor, and because our metabotropic receptor does not have a channel that opens or closes, he changes shapes and becomes activated. This process is called protein conformation. When he becomes activated, he interacts with our heterotrimetric G protein. When he interacts with our heterotrimetric G protein, our alpha is going to lose her best friend, GDP. Because alpha lost her GDP, she's lonely and she needs a new best friend. Her new best friend is going to be GTP. Remember, GTP stands for guanosine triphosphate. And our GTP will activate the G protein and allow alpha to step away from its other subunits. So beta and gamma will stay at home, and alpha and GTP are activated and will go out and have fun. So these two decide that they're going to go see their friend, adenocyclase. Adenocyclase wasn't introduced earlier, but it is an effector protein, or an effector molecule, that converts ATP into cyclic AMP through the process of phosphodiesterase. During this process, phosphodiesterase enzyme takes two phosphate groups to convert ATP into cyclic AMP, or CAMP. So ATP is converted into CAMP. Our cyclic AMP is known as the secondary messenger, and so he's gonna take our message farther. Cyclic AMP decides that he's going to go and hang out with his old friend, protein kinase A. Protein kinase A has a catalytic and a regulatory portion, but our cyclic AMP wants to bind to the regulatory portion. When he binds to the regulatory portion, the catalytic portion of the protein kinase A is going to break off and go floating around in the cell. When the catalytic portion goes off to float around into the cell, it's going to be phosphorylized by some ATP that's also floating around, and that means that it picks up energy from the ATP. Then the catalytic portion and the ATP will be able to go find another protein or an enzyme, which will trigger a cellular response, and that is what ligand wanted to happen from the beginning. Ligand started this process so that he could see a desired cellular response come out. So this is the process using membrane receptors, G proteins, cyclic AMP, and signal transduction. Thank you for watching, and we'll see you in class.